ಇಲ್ಲೂ ಅಲ್ಲೇ ಹೋಗಿ ಹೋಗಿ ನೆನ್ನೆ ಊರಿಗೆ ಹೋಗಿ ಹೋಯ್ತಾ ಊರಿಗೆ ಆಮೇಲೆ ಕಷ್ಟ ಬರ್ತೀನಿ ಹೊಸ ಕೆಲಸ
Sir, you are not audible.
Okay, let me start the session. Good evening, all. Hope my voice is audible and the screen is visible to everyone. Okay. So, with a small introduction about me, those who are joined new today. So, this is Saravanan, PhD scholar and Prime Minister Research Fellow of Department of Civil Engineering in NIT Tiruchirappalli. And I am a Prime Minister Research Fellow, and as a part of PMRF TA-ship, I am taking this course, problem solving session on NPTEL for the course Air Pollution and Control. So, this is my third course in NPTEL. First, I have taken Integrated Solid Waste Management, then I have taken Plastic Waste Management. Now, I'm taking the problem solving session on Air Pollution and Control. So, this is the seventh week we are in. So thanks for joining the session. So every week Tuesday it's happening from 6 to 8. So the first 1 hour it will be the same lecture material what sir has taught in the videos, and in the second hour we are going to take solve the old assignment problems. So we are in the seventh week. So first 6 weeks we are discussed about what is air pollution, what are the air pollutant, and what are their impact on the environment and human health as well as to the materials. And then we have discussed about how to measure those pollutants and or how to model their concentration by Gaussian flow models, and then we have solved some of the problems, and we have analyzed the dispersion conditions based on the meteorological parameters, how the wind flows, how the temperature affects the dispersion of the pollutants and all. Later, we have seen with the emission inventories, how to take inventory for a line source, a point source, or a area source. And then we have discussed about source apportionment. And then also we have last week we have discussed about indoor air pollutants glimpse. And this week again we are going to see about the same indoor air pollution, the pollutants and their effect on human health. Also, at the end, we are going to see some of the case studies related to indoor air pollutant, and we are going to give some recommendation to overcome the indoor air pollution. Got it? I'll move on to the lecture material. Yeah, my screen is visible to everyone, and let me start this. So this is the 31 lecture, and all the material to Dr. Balaram Gurjar of the Roorkee. And so this week we are going to see about the indoor air pollution I mentioned. Last week we are discussing about a glimpse of indoor air pollution. And so what is indoor air pollution? We know as a basic look, we thought it's actually a myth. Only pollutions are only outdoors, not indoors. But as per the statistics we had seen, the indoor air pollutants are 10 times more than the outdoor air pollutants. So we need to think about this indoor air pollutant as a major concern. So that's why we are studying about this indoor air pollutants. AAQ or indoor air quality, AAQ. So these are the major terms. So major indoor air pollutant we will see one by one. And then the effect on children, women, and senior citizens, how they are vulnerable to this type of pollutants. So, as an introduction, as I mentioned, most of the people are 90% they use indoor only, not outside. And outside also they are in sophisticated section of the air conditioner, so they won't be much exposed to outside air. Mostly 10% of in a day. The 90% they will be in office or they will be at home. So there exist lots of indoor pollutants inside the office as well as in the household. So that's what we are seeing here. So increase the use of synthetic building materials causes this type of indoor air pollution. Furnishing personal care products, household cleaners, even perfumes. What personal care products, the perfumes and all we'll be using also will remove the pollutants. That's the indoor air pollution. It's very minute, the outdoor air pollutants. So it can easily enter into our lungs and it will create health hazards. So see here, in the human health, there are two types of effects. So one is short-term effect and the long-term effect, as you all know. Acute and chronic is different. Short-term and long-term are different. Like immediately it will react. It's a short-term effect. That's called acute. And then long-term effect, and it will not create issue immediately, but during a long run, you will feel some of the symptoms. So short-term effect, if you see, no immediate symptoms. We go with long-term exposure. In long-term effect, means due to long-term exposure, like for a year, 2 years of exposure. This will be related to the occupational health hazards. That's what even OSHA, that's the occupational safety and health advisory committee. They have certain guidelines how much a person can be exposed to each type of pollutant, even including heat as well as a pollutant. So, if they are working in a nuclear power plant, how much time they can work? If they are working in a thermal power plant, how much time they can be in a occupational area? So, based on that, if there are the exposure is more than 10 years, they have to have a proper retirement. Otherwise, it will create impact their health. So, long-term effect, they have a respiratory disease, heart disease, and cancer as a major. So, what are the air pollutants, major air pollutants, indoor air pollutant I'm talking about? So, first is carbon monoxide. It will come due to incomplete condition in outdoors as well as indoors. So most of the people still in villages they are need firewood something biomass as a fuel for their cooking. So they have more exposed to this type of carbon monoxide. You can see a black color fume or a pollution coming out of the fire. That are all carbon monoxide only. Then nitrogen dioxide, particulate matter. From everywhere you can see. Even if you see your tables, you avoid magnesium because that are all minute matters only solid molecules. And second-hand smoke that is again indoor. If you see most of the people are still smoking, so they are, that will affect the person nearby. That's called a second-hand smoke. Then asbestos. Now asbestos is banned in India still. Many homes are having asbestos in the old material that will emit some of the fibers that will cause health effects. And then formaldehyde as a chemical, lead. Uh, Even virus bacteria are also considered as air pollutant. Not only physical matters are also considered as air pollutant. I mean, pesticides. Most of the people are using pesticides in their home for indoor pollutants, and then again to indoor air pollutant. Then radon will be not generated inside the home. It will penetrate from the floor and it will be coming into the building. So radon will be generated from the underground earth and then it will be penetrating into the through the floor and it will enter into the home. How to retard that? That all we are going to see here. And volatile organic matters, um, we are using every day. Many things you can say like deodorants and all volatile organic compounds only. Okay. So first we will see about carbon monoxide. So you know carbon monoxide is an acute effect because it will directly replace the oxygen in your hemoglobin. What's the purpose of hemoglobin in your blood? It will trap the oxygen from the lungs and it will take to the heart and it will take the carbon dioxide back to the lungs so we can respirate. That's the purpose of hemoglobin in the blood. But what this carbon monoxide will do, instead of oxygen, this carbon monoxide will merge with this hemoglobin and it will form carboxy hemoglobin in the blood. It inhibits the oxygen intake. People will not get oxygen to the lungs. So it's acute effect. Immediately they will get symptoms like low concentration fatigue in the healthy people and chest pain in the effect with heart disease will come immediately. And moderate concentration, it's a lower concentration. If it is a moderate concentration, people will get impaired vision, reduced brain function. If the oxygen becomes low, so we had seen in the COVID times also, saturated oxygen in the blood level, like SpO2, people see, still people are measuring, doctors are measuring in the hospitals. So, oxygen level will increase, otherwise brain function will get affected. So, if it is a higher concentration of carbon dioxide, what will happen? Again, flu-like symptoms will happen, like people leaving home. Person can leave the satellite. It's don't many oxygen supply to the heart as well as to the brain. So how to reduce the exposure to the carbon monoxide? First, as I mentioned, fuel, coal, wood. Our body with insufficient oxygen will create carbon monoxide. If you burn fully, carbon dioxide will form. If you burn partially, carbon monoxide will form. Keep your fuel burning appliance in good working condition. You see some of the vehicles, if you see, it will create a black color emissions. If your vehicle is in good condition, it will not emit this type of more outside. If you are cooking appliances, burning appliances are in good condition, then it will not emit carbon monoxide. Then the heating system, never burn charcoal indoors. Not leave a car running in a closed garage. That again it will create carbon monoxide. Instead of use an exhaust fan venting. So this will prevent all the pollutants. So we need to have a proper ventilation system in the indoor because ventilation will dilute the concentration of the pollutant. So ventilation is very important in all pollutants. Okay, the nitrogen dioxide, NO2. So what it will cause if it is in a lower level, it cause increased bronchial reactivity because NO2 go to the lung and everything will be related to respiratory illness only. Increased bronchial reactivity, decreased lung function. So that's called chronic obstructive pulmonary disease, COPD, they will say. Like it will create a congestion in the lungs. So it will increase the risk of respiratory infections for any it's some kind of asthma. Okay, it create a irritant effect in the mucus and may result in pulmonary edema and diffuse lung injury. And exposure to high NO2 level will cause the development of acute bronchitis. Bronchitis again a disease related to bronchitis. How to reduce this exposure to N2O? Keep gas appliances in a properly adjusted condition, maintain space heater, use proper fuel in kerosene, space heaters. Then install and use the exhausted fan. Again, ventilation is very important. Open flues, fireplaces are in use. Don't idle the car inside the garage. That again that will create that. This one is a major cause for indoor air pollutant. Car in the garage. Then particulate matter again it's a major indoor air pollutant. So health hazard related to the it's a so fine particle. So in the sense PM10 and 2.7. PM10 is the kind of particle whose aerodynamic diameter is less than 10 micrometer in size. So that's why it's called PM10. So people with heart or lung disease can be severely affected by this PM10 like coronary heart failure, asthma, COPD, and children and older people. Everybody have different risk from PM exposure. So that we have to take care. Aggravation of respiratory diseases, premature death in the people. So how to reduce this exposure? Install and use exhaust fan again ventilation is so to properly size the wood stoves, appropriate wood in the stove, train the professional inspect to clean up heating system and change filters and heating and cooling systems. So that is again an important thing. HAV like heating and cooling systems and all need to be properly cleaned every time. So again, fine particles may have different sizes like PM10, 2.5, 1 and 0.1. You can see the entry path. The PM10 can enter to the lungs, to the respiratory tract. PM2.5 can enter into the lungs. PM1 can even enter into the blood vessels. Point 1 can travel to whole body. So coarse particle, fine particle, very fine and ultra fine particle can travel all over the body and it will create heat effects. Like coarse particles may go respiratory tract. Fine particle may go to lower respiratory tract. Very small particles may enter into alveolus. Ultrafine particles may enter into blood vessels. So this coarse particle not there in the this is what I have described. So think about the size and its health effects. So the fourth important pollutant, indoor air pollutant is second-hand smoke. Second-hand smoke is the one people who is smoking will affect the person nearby. That's called second-hand smoking. So health effects by second-hand smoking, cardiovascular disease, lung cancer, sudden infant death syndrome, asthma attacks, health risks to children with asthma. They will be more prone to this type of smoke. And even I have breathing issue like mild wheezing. If people are smoking nearby, I will get immediate cough and respiratory symptoms. It's called second-hand smoke effects. Then, how to reduce this exposure to the second-hand smoke? Eliminating second-hand smoke is the first point. Indoor environment, it's not very important. You should not smoke in public and then indoors. So you have to have a private place for this type of pollutions and comfort and health of occupants is very important. You have to consider. And then voluntary smoke-free policy implementation is can be done. And then it's mandatory and voluntary for a multifamily housing. Then asbestos. Asbestos is a pollutant, indoor air pollutant. So exposure to asbestos increases with developing lung disease again. So people will be difficult to asbestos related condition can be difficult to identify because it's a fiber, chemical fiber. So it's difficult to identify. It's because of asbestos. So again, health effects like cancer, mesothelioma, and the thin lining. That's the condition of thin lining on the lungs. So you can find partial fibers on the lungs and liner. And then asbestos is a serious progressive cancer disease of the lungs. So it's a condition, asbestosis. Um, people like farmers, they have a pharmacies like that asbestosis. People working on the field, they have the same problem. It's called the silicosis and the same name will be built to the pollutants variants. The same asbestos will be related to asbestosis. It's the deposition of this asbestos fibers on the it will form a thin lining on the lungs. How to avoid this again? So you can see here the asbestos sheet, how it will be. So it can easily emit into the atmosphere. It will cause. So more disturbing material that contain asbestos and including pipe, furnace, insulation, sliding and flooring. You should not always make it wear and tear. And then higher contractors, they can work maybe with this type of safe asbestos removal and disposal to avoid contaminant. So using wet cleaning methods because it will not enter into the exposed into the indoor environment, it will be deposited and high efficiency cleaning vacuums like HEP vacuums, vacuum cleaner kind of. And then using doormats and removing shoes before entering, that will also reduce concentration of asbestos in the home indoor environment. Not only home indoor environment. And formaldehyde is the other indoor air pollutant. What is the effects due to formaldehyde? It will create raised throat and nausea infection. So even zero point 0.1 ppm parts per million will create this type of symptoms. High concentration may trigger people with asthma, and there is evidence that some people develop sensitivity to formaldehyde. So it can also cause cancer to the human. So formaldehyde is carcinogen. Carcinogens are the one which can cause cancer. Then how to reduce the exposure of formaldehyde? Ask about the formaldehyde content of a pressed wood products. Whenever you are using any foundation wood material to your home, ask for formaldehyde free or formaldehyde in this type of furnitures. And then rate at which the formaldehyde is released is accelerated by heat and depends upon the humidity level. So if we it's also based on like outdoor air environment, indoor air meteorology will also play one role in emission of rate of release of formaldehyde. Even lead. So lead will affect directly enters into the nervous system and it will affect the kidney, immune system, reproductive and developmental system, and neuromuscular system. So lead exposure affects the oxygen carrying capacity, same like carbon monoxide. So it will have a direct effect on the neurological behavior in movements. So our neurological affect system will get affected. So how to reduce the exposure to lead, where it's coming from? Like mental environment here, lead-based paints. So when it's coming from paints, that lead will enter in the so we have paints in every room will be painted. So now we are doing it's lead free. Whenever it get eroded, how it is entering into the interior, how it will be entering into the human bodies. That will be affecting for doing to the walls. So implementing paint surface is an excellent shape and lead sense of using this kind of like lead paints. So use proper ventilation and equipment when melting lead to cast bullet sinkers. So this again it's in the industrial application. In industry is a Indian problem. So we have to use a proper ventilation and equipment to cast bullets, sinkers, and other metal items. Okay. And then volatile organic matter. Again, it has health effects like eyes, nose, throat irritation, kidneys, coordination, liver, kidney, and central nervous system, cancer in animals. So all the body parts will get affected due to air pollutants. So where it is coming from the volatile organic matter, how we can control to increase ventilation, provide plenty of fresh air, throw away unused containers safely. Because whatever the paint container or any containers we are having will emit organic matters like our turpentines and all, even kerosene in the home or any fuels. As I mentioned, uh, fresheners, everything is volatile organic in matter. So whichever converting from directly from solid to gas or liquid to gas, that are all volatile in nature. So what is the name of the we are using the bathroom fresheners and it will simply convert into solid to gas. So that is a volatile organic compound. Even as it's because it's smelling, it's a benzene. It contains a benzene ring, as I mentioned in the last class. So it is again it create health hazards. So never mix household care products unless that on the label. So if you are mixing any two household care products, it will also emit volatile organic compounds. So throw away partially full containers or old unneeded chemicals. Chemicals, that's what we are having in the home. So that need to be properly disposed. Contaminants. Not only, I think only the air and carbon dioxide, nitrogen dioxide, this type of H2A, sulfurs, nitrates will cause air pollutant. Even biological contaminants are also considered as air pollutant. So what are the biological contaminants like COVID? How it spread through air only. So COVID is considered as the air pollutant. It's a virus. Same similarly, all kind of biological things like bacteria, everything are air pollutants. So allergic reaction that can repeatedly exposure to the specific biological allergens like bacteria, fungi. Pollen is from sunflowers. You can see like small pollens that will be of small size that will also enter into the nose. So people having running, sneezing conditions are due to pollen exposure. So people having wheezing, they are not advised not to take walking in the morning because pollen may be more in the air during daytime. So it is again a air pollutant. Pollen is a air pollutant, but it's a biological contaminant. And like mold, dust mites, pet dander, because it's coming from pet hair. That's a dander. Dander is considered as a air pollutant. Then we got tuberculosis. Then, how to reduce this type of exposure to biological contaminants? You can install and use exhaust fans. Again, ventilation is the major steps to reduce this type of all the indoor air pollutant because indoor it is concentrated because of lack of ventilation. We get proper ventilation, we can avoid the concentration or we can dilute the concentration of indoor air pollutant. Ventilation, the attic and crawl spaces, it is we'll say like closed moist area. That and all we need to ventilate properly. Thorough cleaning and dry water damaged carpets. Okay. Then pesticides. People are using lots of pesticides indoors. So that is a case study. I will also show the case study. Most of the last week, I think, seven out of 10 households are using pesticides for their crops in the home itself. So they are directly exposed to this pesticides. Pesticides are again a air pollutant. So it will damage the central nervous system. It will cause irritation in the eye, nose, and throat. Increase the risk of cancer. It's a carcinogen. So pesticides is considered a carcinogen. That's why we are not using even for the crops. Fungicides, insecticides, pesticides, nothing we are using for the crops nowadays, right? We are moving to organic pesticides because it's a because pesticides are identified as carcinogen. So what are the symptoms? I think dizziness, muscular weakness, and nausea. So that will damage the liver, kidney, endocrine, and nervous systems. So both the active and inert ingredients in the pesticide can be organic compound. Again, it's a organic compound that both could add to the level of airborne organic inside the food. How to reduce that? Ventilate again. Use of non organic control method. You can use strong receptors control. You can use oxygen, any kind of spices you can use as pesticide because this will not be adapted to this type of spices. And then dispose of unwanted pesticides safely. Keep the exposure to both repellent to a minimum. Then use only the recommended amount of mix and dilute pesticides outdoors. So you should not apply pesticides as much you want. You have to have a recommended value to apply. And mix also you have to do the required quantity. Don't mix whatever you want. You mix pesticides outside the home. That will reduce the concentration of pollutant inside the home. Radon. Radon is again considered as a indoor air pollutant. It is not created inside home. It is coming from earth. So it is a health effect because of it's a lining. It will line your lungs and gives off radiation. So radon is the radioactive material. So it release UV um, radiation. So the symptoms like coughing up blood, chest pain, losing weight without so symptoms of exposure. So the radon mitigation strategy, let's see, this one will be okay. I have a picture. No, maybe in the upcoming slides or last week we have discussed, I guess. So radon is coming from where it is coming out. It is coming from the ground. Sorry. It is coming from the ground and it will reach the uh, floor of the um, building and it will enter into the household. So that's the problem with this radon. But how to trap that? You have to have a gas permeable layer at the bottom and plastic sheeting through that gas permeable layer. Then sealing and clogging go there. Then use pipe if anything get uh, collected in this. They have a pebble layer. So that's a pebble layer. Drainage system, multi-drainage system. we say we will have right rainwater harvesting system and all like that pebbles we have. So whatever will be taken through a pipe and it should be emitted outside above the building. So that's called vent pipe and a junction box for a proper operation of this. So that and all required mitigation system for it is recommended that the home be tested for radon on the lowest land lived in the land because it will be always more ground floor. Lowest floor available will be one floor levels and these ground floors. So we need to have a gas permeable layer with a solid to like that, and then plastic sheeting to trap the air, and then sealing and the clocking. It's a concrete foundation floor only. And then vent pipe that will be of 4-inch diameter that will allow the gas to pass through that and it will be vented out above the house, above the roof of the house, and then safely. Then junction box, electrical junction box is installed for the operation of this mitigation system. Then these are all indoor air pollutant and their effect, how to mitigate this. That's what we have seen about the indoor air pollutant. Now, who are all the vulnerable population? Like women and senior citizens. Because of that, infant and young children have higher resting metabolic rate and rate of oxygen consumption per unit body weight. So exposure health risk is always directly proportional to the body weight. I mean, indirectly proportional to the body weight of the human. If it is human health, you have to put with the body weight. So people will, I mean, children will be having less body weight. So they will have huge health risk. That's what it's directly mentioned here, like metabolic rate and rate of oxygen per unit body weight than adults. So they have high. That's why exposure to any air pollutant may also be higher. So children have narrow airway, pathway to their lungs. So without the pollutants, it will get trapped and it will congest the lungs. So that's what again a serious problem with the children. So I have seen responsibility something to just significant obstruction. And people who like chronic obstructive pulmonary disease (COPD), such as because women, most of the Indian women are still uh, living in their home. So more exposure to even in villages, you can see like grandmas are using as so COPD, chronic obstructive pulmonary disease are happening more in women compared to men. So 1.5% of death in India and 16% of death in China are due to COPD. Lung cancer also spotted more in women because we are using cooking with open coal stoves and cataracts. Cataract is again blindness in women, again is found in women using homes. So these are all case studies results. And if we are using still biomass as a fuel for cooking, they have this technique in uncontrolled cataracts and COPD. So they are moving to LPG, and now because of the problem with LPG, we are moving with the CNGs and then switch stoves. This is filters. Again, due to exposure with the smoke, see here the carbon monoxide level. And, it is the adjusted risk. Adjusted risk is the value that will make you easier to compare with other population. So women are having 2.7 times adjusted risk means compared to men or other population, they are having 2.7 times higher risk for tuberculosis for solid fuel using humans instead of LPG and any gas fuels. And then adverse pregnancy outcomes (APO), still both low birth rate and low birth weight of the infant, early infant death. Associated with the pain. Infants are also always will be with the women. They they will feel from them. So everything will be directly related to that. So the kind of population are always related to Indian population. And then senior citizens with a breathing problem. They usually most of the senior citizen will have breathing problems like asthma, condition of breathing. So their heart will be weaker, so it will get create increased chance of heart attack. Vulnerable population to the pollutants. And a conclusion note, you can see the link between air pollutant and the human effect will be directly linked. And radon is a human carcinogen and carbon monoxide is toxic. Short-term exposure itself will lead to lethal. Lethal in the sense You got it. So these are all indoor air pollutants and their mitigation measures. Not mitigation measures, we can avoid the exposure to the indoor air pollutant. And how to assess the exposure to the indoor air pollutant? Each pollutant, how to assess? That's what we are going to see now. So, assessment of exposure for each and every pollutant. What are the samplers we can use? Assess in the sense level. How much concentration of each pollutant, like particulate matter, how much, radon, how much, how to measure, how to sample and measure. That's what we are going to see here in this lecture. So, first assess, we need to know how much concentration is there. Then only we can design any treatment mitigation option. So, if we know the exposure, we need to know the concentration and the exposure time that is a factor. And the exposure factor that is the time we are taking. Okay, so concentration in exposure time will give you, sorry, time will give you the exposure. So based on scenarios, it will also vary. Based on source, based on concentration, based on transporting mechanism, and the population code, the exposure factor will also different. So we need to know how much concentration is there. That's the aim to assess the pollution level, the indoor air pollution level. So general aspect of exposure level is first in building investigation people will need because to control compliance with the existing guidelines or recommendation whether the building is having proper compliance with the existing guidelines or recommendation that we need to know uh, after constructing the building because there is no ventilation in a building people are not allowed to stay in and this is outbreak investigations we can go to the air quality monitoring and population or environmental investigation we can use so exposure assessment in a epidemiological studies like so having a relationship between indoor and outdoor airborne environment of exposure. So you can see here much air pollution levels things may also have things may have smoking may have outdoor pollution and even purifiers may have. So those are all causes of air pollutant. So there may be a direct relationship with this indoor air pollutant with the outdoor air pollutant also. That we can that relation we can maintain. The overall goal of this investigation is to improve the understanding of exposure and its health impacts. So if we know, if we have a proper data on health impacts of a community, then we can also correlate what are the causes for this health effects. Even all the, if you see about water related concentration, if you see yes 10,500, if you know about yes 10,500 code information, Indian Standard Code that gives you the standard parameters of water and the quality parameters for drinking water. It's a drinking water quality parameters guidelines. So even for the pH what is the level, is a level. What is the level should be in the drinking water. So how each pollutant level was fixed. Why they fix for why they choose an mercury instead of other elements? Why they choose an arsenic instead of other element? Because everything already caused a health impact to a community. So based on that, they have tracked the pollutant and they fixed the level should be maintained. So even mercury they have identified in disease. Arsenic they have cadmium they have identified completely disease. So the public got affected, community got affected. So silver because of syndrome. So everything have a disease when they have placed and guidelines. We need to know exposure assessment. Sampling design, how to get a population, how to know number of samples, what is the type of sample we can do, sampling methods we can do. So study of all subjects from a population. So each and every person you are going and measuring. That is a all subject from a population. Then simple random sampling. If a population is homogeneous, then we can take anyone. That is simply random. We can choose anyone. That is a simple random sampling method. Which each of the population may have equal chance of exposure. So simple random method we can use. So this is a simple method. In the hundred, we can choose uniquely. Because all the hundreds are homogeneous. All the hundreds are doctors. All the hundreds are working as a homemakers. So all the 100 people are students. So we can take any five because all are homogeneous. This is a stratified random sample. We have to use homogeneous. First 10 are doctors, first 10, other 10 are engineers, other 10 are plumbing people. Like if all these status are there, then each one strata we can choose one randomly. That's called a stratified random sampling method. Then systematic sampling. The sample is chosen by selecting an element of the population at the beginning with the random start. Then for every kth element, we can fix a number. For every kth element is selected until the appropriate size of the sampling should be. um, So we can choose first one, and fifth one, tenth one, fifth one. Until I get a proper number of samples, I can go with this. Because we need to have a consistent or realistic results, right? Simply. I can take a question of people. Uh, Go with the individuals. So other two type of samplers are there. One is active, that is sampling. This is samplers. So there are two types of sampling. One is active sampling, another one is passive sampling. Active sampler is the one will have we say to pump out the air and it will measure. So how we need the energy, the air and it will measure. Passive sampling relies on the kinetic energy of the gas. So whenever the gas passes through the sampler, it will emission. It will not suck the sample inside the sampler. So that's the difference between active sampler and passive sampler. Same we can apply in landfills also. In a bioreactor landfill, if you know it's a landfill, we are supplying the gas. When now the gas collected, we need to be supplied. Now the leachate collected, it will be supplied again. That's called a bioreactor landfill. We have to using the anaerobic conditioner landfill, we are supplying the gas and the leachate again into the landfill. So that are again two types. One is active, passive. The gas that is collected will be pumped through. This is active. Gas is moving in based on kinetic energy, then it's called a passive landfill. Same samplers also. Then active sampler requires some power, as I mentioned, because to pumping we need some energy. But passive sample now depends on any source of power supply. Okay. Then for each pollutant, now what we have discussed, we are going to know what sampler will be suitable. Fine. So first nitrogen dioxide (NO2) we are going to measure. So what we can use is the approach method. We have a monitor for a certain period. Most active samplers collect active samplers only here we are using where we need to suck the sample. And NO2 over a period of several hours we need to take. Some pollutant need smaller measurement time like ozone and then this kind of thing will easily into O2 and O immediately. So we need to take sampling to 8 hours only. Carbon dioxide and all will have 24 hours sampling as are required N to O. So several hours sampling is required and it is expected because so, directly determining the exposure of NO2 using passive samplers we are going with. Passive samplers having an average concentration over longer period, you can see deposition of different uses. So this is called a tube sampler. We talked a little about the tube sampler. So there are low sensitivity samplers. Sensitivity tube are type sampling. The tube, as you can see here. So sampling have a faster sampling rate suited to short term. So it will absorb the N2O on it and that can be measured separately. Then in approaches, we using questionnaires. Questions would relate to the presence of oxygen or one or more indoor NO2 source. So if the N2O source and NO2 source are we go to the atmosphere. So based on the questionnaires, we can go with that is the indirect approach of measurement or assessment of N2O. So next step would be assess exposure of NO2 by measuring its concentration in the air by micro environment visited by the population and by maintaining information on patterns of human activity. Micro environment means not as a whole city. We can go with the kitchen. We can go with the like halls. Like micro environment, we can measure. So these are all after indirect measurement of N2O. Yes, sorry, NO2. Then volatile organic compounds. How to measure that? Again with the bad samplers. That's the direct measurement method. So passive personal tubes are batches containing the solid adsorbent because VOCs are gases that can be absorbed with the solids. Like any adsorbent like activated charcoal or activated carbon, anything can absorb this type of VOCs. So most of the air pollutants also they are using this as a adsorbent. So you can use any solid absorption. Absorption is different. Absorption is different. Absorption is if you take a sponge and put it in the water, it will absorb the whole water. That is called absorption. But if you put carbon on the carbon on a pollutant, then it will be due to its surface area and surface pores. All the pollutant is getting absorbed into the pores. That is due to the surface area. Then it is called the adsorbent, not into the material, only on the surface. That is called absorption. Absorption. If it is going to the body of the material, and it is called absorption, like water is absorbed in the sponge. So, any solid adsorbent can be used to absorb the volatile organic matter that can be measured separately. That's called passive sampler again. Cannot be used for short term, and active sampler must be applied for short term exposure period. So, based on the exposure periods, you can use samplers, active or passive samplers. Impact measurement is like micro level concentration data and personal time activity data, like the personal data you can use. Monitoring VOC concentration in microamino can be easier than monitoring personal exposure daily. So that's a grab or whole air sampling also we can use like Tetler bags. Tetler bag is like a carry bag with a knob. So that can be used when the sample in sample. Then you can lock it and you can bring to the lab and it can be measured. That's called grab sampling. And the whole air sampling can be grabbed and you can measure. Then formaldehyde. How to measure the formaldehyde? It is only used in occupational settings but not in the non-industrial environment. So use pumps to draw the air through impinges solvent. Impinges, I will show the diagram. It will be like if you are in a lab, you know about measuring cylinder. A glass cylinder will be there, right? So like that, it will be closed measuring cylinder. So like, it will have a tube going inside, and a tube will be at the top. So simply, it will be like this. A tube will go in, and a tube will be there at the top. So you have to connect with the sampler. It will be a closed one. So all it will contain a liquid solvent to absorb. So it have a liquid here. So water any solution is used to produce specific pollutant. If it is carbon dioxide, we can use KOH or KOH solution can easily NaOH solution can easily absorb CO2. Like if it is sulfur dioxide, you can use separate adsorbent. So water also can be used to absorb particulate matter. So based on formaldehyde, which a solid absorbent is good, that can be filled here, and the impinger it will pass, it will mix in this solution. Only the formaldehyde free air will come out. All the formaldehyde will be getting absorbed to the solid or liquid solvent. You got it? The solvent. So gases going forcefully because it's coming in high pressure. So bubbles will be formed and formaldehyde will be solved formaldehyde free in the form. That's called impingers. I can show you the impinger diagram here somewhere. It was there. This PPT was there. Okay. Then I will show you in Google if possible. Yeah. So it will be like this. So could you able to see this diagram? Yeah, it's probably uh, yeah, it will be like this. So a glass tube having a knob at the top and a floor at the right side. So it will go in, it has contains a solution. Then the solution can be taken and tested for formaldehyde or any type of pollutants. So only the so you can have series of impingers. I will see here you can connect series of impingers. Uh, See here, or in the old diagram also it was clear. So four impingers are connected in series. So first, will be used for CO2, second will be for SO2, or first will be for particulate matter CO2, SO2, N2O. So for solutions, for separate solvent, I can prepare for each pollutant and I can fill in this. So it will be connected in tubes. First, it will go in through the first impinger. PM will get absorbed and all other PM free air will go into the second impinger. It will be at high pressure and you have to suck out through the other end. So it will go through the tubes and it will come out at the end after getting absorbed each pollutant and each respective solvents. You got it? Yeah. Okay. Now, how to this is the direct method. So temporal variation in the concentration may also be identified with this type of samplings because every time you are taking the impinger and measuring, and then every 1 hour you can have temporal variations. I mean, variation you can have. Use of occasional short-term measurement also may not provide a representative sample for exposure. Carbon monoxide, personal and micro environment, CO levels can be continuously monitored with this type of electrochemicals. Can be used to monitor CO. So as I mentioned, carbon can be measured with NDIR sensors, non-destructive infrared sensors. You can use to measure carbon like CHO, CO2, CO, anything can be measured with NDIR sensors. So that's and principle you can use to measure the carbon monoxide level. Size and weight of the personal CO monitors been reduced to those as portable small portable equipments we have nowadays to measure the carbon monoxide level. And you can Google it or in Amazon also you can find lots of indoor air quality meters are available. That will show you what is the carbon monoxide level, what is the ozone level inside the home. So smart homes they are having nowadays all these features. Then carbon monoxide sampling tubes have also been developed and tested. See here, like principle of diffusing carbon monoxide molecules onto the absorbing medium palladium chloride. So you can see medium palladium chloride here. That's a sampler. So that will get absorbed on the palladium chloride because carbon monoxide have more affinity towards palladium. The formed metallic palladium can then the photometrically can be determined with specific reactions. Then the sample is composed of polypropylene housing. See here, plastic housing. If you open it, chlorine and whenever carbon monoxide is reacting with the it will form metallic palladium. So, metallic palladium is good can be instead with photoreactivity. Because palladium metal have photoreactivity. So, if you pass light, you can measure how much metal palladium is there. It can be directly proportional to how much carbon monoxide is there. So, okay, so it will be 20 more. Instrument. It's a passive sampler because no need to force the air into it, right? So this is something. And radon. How to measure radon? Radon concentration is monitored by various indoor spaces and information and activity patterns is collected using questionnaires. Um, See here, radon can be sample again. Activity samples with billion research detectors because it's a real material. So how much alpha particles is being emitted, but it's how much radon is there. And also detectors are progeny. So the important thing is radon is measured in terms of becquerels per metric whatever radioactive material that will be measured with becquerels. Quarrels is a unit and becquerels is a smaller dimensions. Becquerel per meter cube of unit. You can see here alpha particle track film. That's for personal. You can hang on your. It's like a ID card. You can hang and you can go through the room and measure the concentration of radon. Like screening aims at detecting high resolution over 3 to 7 days to over variations. You can measure for 7 days in a week and you can find out variation. And sampling should can be going point in the building. That's what I have mentioned. Radon will be usually more ground floor or underground. So you have to measure the lowest point in the building. And then particulate matter. Particulate matter can be measured directly by gravity method. You can use particulate number, particulate size, distribution matrices. And then it's the gravimetric method and beta attenuation are the two methods. Gravimetric is very difficult. Beta attenuation is direct. It's not about sorry. Equipment method. Then particle number concentration is measured by condensation particle counts, optical particle counters, and diffusion particle. Optical particle counters like a tape will be there, and the air will be passed through the tape. Whenever particle matter is there, the tape will have a gun, and particle will stick to the gun. So it will be passed through this. So whenever there is a tape is transparent, more will be passed. Whenever it has more particles, then the transparency will be reduced. It will become opaque. How much the transmittance will be proportional to the particle. I mean, how much reduction in the light part passing will be directly proportional to optical method. So, other low cost sensors are also available nowadays, allowing specific studies to inform the future of experimental studies. Then asbestos human samples examined by light or microscopic analysis of individual fibers. And this enables the long-term exposure to persistent fibers and short-term exposure to less persistent mineral fibers and or magnetic fibers. Yeah. Also, because it's a when it's a CB, we can filter it with the memory and we can pass the results and we can say, how we can filter from with the membrane filter, and this will be again used to concentration. The second-hand smoke. Second-hand smoke may be directly proportional to particulate matter. So you can use particulate matter as a non-specific indicator, and reporting in containers and use a markers. So indicators are markers used to measure second-hand smoke. So stationary sampling pumps and nicotine can be glass paper. Chromatography with flame ionization detectors are the equipment used to measure second-hand smoke. Samples of respirable suspended particles. Respirable suspended particles is PM. Or it can be used on fluoroprene filters. Several filters you can use. Again, this question is we can use how much tobacco smokers are there. Based on that, we can do how much smokes will be there in the environment. It also based on type of the building and ventilation system, highly correlated with PM10 and 2.5 indicators. Then personal exposure to the pesticides. Pesticides again can be personal use monitors. Personal information how many people are seeing exposures and methods of measuring dermal exposures, because it may be there are three pathways. One is inhalation, that is through nose, inhalation, inhalation through food, through the mouth, and the third one is dermal, through the skin. So these are three related to our body. So pesticides can be entered through dermal exposure, and all the air pollutant will be through inhalation only. And then biological monitoring of pesticides varies with substance of interest. Like any biological anything you can do. Pollens. Pesticides metabolites are analyzed with the gas chromatography. GC will be used to on become the impinger. So samplers such as impactors or impingers are with sampling directly filter and microscopes. Then you know the microscopes you have seen lessly. So we can Lipopolysaccharides, so that's directly proportional again. The indirect assessment of bioaerosol exposure, so the foam surveys and the exposure assessment from this specific GL. This can be taken as an indicator. See the samples will be using give you the exposure into instruments the specific indirect exposure through filter PLD. The three types of methods are available, particularly in the numbers, in the count, saying of might allergens, and guanine determination. These three are the methods of determining determination. For trace and gas leaking method. So to know how much leakage is can do if you have a building, you don't need to know the building is properly ventilated or not. You can use any tracer gas. Um, because we will use water pollution modeling. Water modeling like it is used we will have ammonia there. And after some time, after 1 kilometer, 2 kilometers, we will take the sample and measure the chlorine concentration. And before adding chlorine, I need to know what is the chlorine concentration in my water. If it is zero, fine. If it is two, I have to subtract two from here. And whatever the concentration is already, it will deposit with the and only if I have it in generally these two, we can get it here. Only four grams say disposal same I can use tracer tracer. And if you don't need to know the groundwater flow, I can have it in the borehole, and after some time you can do samples from different boreholes and define what is the flow. If it is going through this way, only it will be at this point. No other borewells will not have any dye. So that is used as tracer. And you can even you can use any tracer gas and it will have leakage. So there is release after mixing with the whole indoor environment. This monitor sampling will be there. Window. How much ventilation is there? We can easily measure based on the slope of a semi-logarithmic plot. So the equilibrium concentration method is you can use the tracer gases released at a constant rate. Indoor concentration will reach a steady state. After reaching that, you can inject the air and the filtration. So devices you can use to measure the mechanical ventilation. Ventilation. They include pressure measuring devices, velocity measures, meters, and mechanical glass flow indicators, tracer gas techniques, and heat balance techniques. But different monitoring devices like as I mentioned, temperature, humidity will also play a major role in portion or emissions. Thermometer is a good thermometer. It's kind of thermometer only. The thermocouple semiconductors and thermostrats parts are used to measure the temperature. So, the temperature. Temperature gradient can be larger in buildings and even in the individual rooms. And that humidity can be measured with dew point micrometer. So that's the measure of humidity. So you know principle exposure assessment is important to know how much pollutant is there. So exposure measurement can be even passive samplers can be used to samples. So you need to okay. So modeling same we have modeling for another like Gaussian blue model, model. We can also model so estimating the amount of pollutant. We can model how much it will be there after some time or after some distance. So estimation of emission, fate, and transport of inter-air pollutant can be found with this type of models. Because most of the people spend portion of their time in indoor. That's a major point. 90% of the time is spent indoors. When field testing is costly, time consuming, and physically challenging with models. So modeling, developing a set of mathematical equations. Statistical models are learning experiments to link inputs to the outputs, and determining models of physical and chemical scenario, and then solving the equations to simulate behavior of the realized systems. The process of using models to analyze the behavior of the realized system is called simulation. So we'll model and we will simulate it. So model will run in one direction, simulation will run in another direction. Model we have to do with set of data. Simulation will give you the set of data for future. Or running the model. That's called IAQ model, indoor air quality model, are developed to understand and predict the indoor air pollutant concentration and dosage. So we need to know what the source and sink where it is coming from, where it is going to get disposed. That's called outdoor air pollutant concentration and indoor air pollutant we can find it through these models. So what is the advantage of the IAQ modeling? We can know what are the source and sinks of the building the building factor that will affect the air quality. It is used to investigate new problems. The numerical modeling is using computational fluid dynamics, CFD. Most of the people are more familiar with CFD softwares. So that will, because air as a fluid, we can use computational fluid modeling. Special programs for room movement and codification. We can use in the transportation mechanism visually. And then the air jet diffusion, air velocity, and temperature distribution in the room can be predicted. So here you can see this will be the animation you can find. If it is emitted from people, if it is emitting from the source, how it is from people, and what is the concentration you can find. So these are the question laws. The question of energy. These three are the basic principles used in CFD. So it's the fluid motion. CFD is the tool used for analyzing fluid flow problems. It uses the method such finite element method, finite difference method, finite volume method. So three are the this during the finite element, you can find each it is here this much element how much it will be. That's called finite element method. You can study modeling. If we are in everywhere, you can study this element method. Simple modeling techniques like at least on order of magnitude assessment, like model, box models, or three model techniques used. Only analytical models for two just mixed model, partially mixed ventilation model. So well mixed model usually spatially uniform within the closure because everything is mixed, easily mixed and reactive. Usually fluid CSTR kind of in water. Same we can use for air quality. That's a well mixed model inside the box or inside the enclosure. Partially mixed model is of pure poor mixing, not form. Same assume well mixed condition to assess the quantity. So mass concentration the time equal to zero, you have assumed some quantity in mix them. We can find one and so we know we can find the result inside because the source is emitting the pollutant at a constant rate. So equation of conservation of mass, based on that you can the model. Induction model can be used to know the sources move within inside space. You can find mobile inside the tunnel, smoking inside the room. So these are the examples we can use for say for induction model. The movement itself is outside the spaces. And specific control volume approach can be used here. Like advection model uses this, and you can find the concentration of current with this equation. And box models assume it's an enclosure with an uniform distribution. Multi-cell walled mixer model, mostly used in the indoor environment. So it has four mixing to move it's something that moving at the other direction. That is called a displacement. One is displacing the other. Then if it is moving directly, then it is called a capacity. If it is coming in one direction and moving in another direction, it is called a mixing. It's not displacing, it's mixing the air inside the environment. It's then moving from one, then disposing concrete piston. So that's the concrete and existing slide like a cylinder effect. So these four are the types of box models we can use. So air quality programs are there, like software programs. And on first told is the EAQX. It's the enhanced exposure and Windows semi models. SVOC we can use the parameters PRAM program we can use for. So I just run up with this models. I will show you one day especially for this type of models. So the models I will show one day. Okay? That is possible. IAQX, they have a different programs that will simulate you the the model that the interface of the model. And then SVOC, ISVC is specifically for semi-volatile organic compounds. Then the limitation here is single with and single SVOC you can find does not support chemical reaction. There is no reaction is happening here. This is the definition of Mark principle. And then params we can see here. The parameter on Microsoft based software and the is using leaking space, liquid phase, the overall mass transfer they are considering and volume, solid air, partial coefficient, vapor pressure are considered. It saves more time, but the limitation is only a fraction of total number of parameters. So the only 7 we are considering, right? Not all parameters known limitation. So these are all important models they have developed for interior quality. It's based on statistical mass balance and computational fluid models, which uses three software, only science, VOC and params. So if you are going with the technology to mitigate the indoor air pollutant, again, if you are going with every will be only major overview concept used to mitigate the indoor air pollutant. So important to avoid health risk effect, we need to mitigate the air pollutant. Example is important oxidation. Oxidation. The important we can use for oxidation of pollutant. Like absorption, we can use increasing the amount of outdoor air coming indoors, like windows, doors, we can use. There's the source control. That's the main point. You have to avoid the source that there won't be any indoor air pollution. So source avoidance or improved ventilation is the second point. So ventilation it can be a natural ventilation or it can be a mechanical ventilation. Like continuous supply of exhaust fan, air cleaning, clean ways clean door air, instant air conditioning system, PAC system to improve the environment. So type of cleaners you can see, bottom cleaners use. Some of the cleaners are also available in Amazon. You can find most of the things with clean your clean. So actually in technology you can see for particles, you can use filters, electrostatic precipitators, ionizers. For microbes, you can use UV. For gases, you can use oxidation plus and ozone channel. Intentional ozone. Because ozone mirrors pollution. Still, intentional ozone creation will see some of the cases. And there are two types of calculating technology. One is fiber media filters and electronic filters. Fiber media filters will also capture the fibrous filter material, capturing the not the fibrous filter material. Depends on number of parameters included, like particle size, filter thickness, everything based on that. It will be a flat or a panel or a plate. Plate will be like um, stacked thing. So filters we can use. Based on the efficiency, high efficiency filter, high efficiency particulate filter, HEPA. So based on that, any RV and you can see ERV, minimum efficiency reported value will be 1 to 4 for plant in the air panels and for plane it will be 50. For high efficiency it will be 14 to 16. So based on the efficiency, you can find different filters. Electrostatic precipitators, there will be two electrode, what will be positive, what will be negative. So the air will be passed through that. And, there will be a corona discharge. Through the corona discharge, the corona charge like, so the corona will be that's a charge will be discharged through a charge. So that will be whenever the air have any particles that will be charged with the corona discharge and it will be attracted to the respective electron. If it is a negative charge, that will be attracted to the positive electron. The particle will be removed from the air, so only the clean air will be coming out. So that's the principle of electrostatic precipitator used in the air quality cleaning methods also. Control methods we will see in the upcoming weeks in the industrial air quality control methods. But the iodizer or iodide generator have high voltage brush technically the air quality. The air temperature to the weak that is wall to the texture that will give you so this is the UV. Now UV have a property. So you can clean the air, will consider the air UV irradiation, germicidal irradiation methods. Again, there have different types. 99% reduction in the microbial exposed HVAC surfaces and 20 to 30% reduction of airborne bacteria. Disinfection method. And then sorbent we can use for cleaning the air, like air filters, photoreceptors, small intentional ozone generators. None of this technology are explicitly designed to remove particles. So we need to have a sorbent media that will be specifically for actually consumption and absorption, as I mentioned. So you can use any sorbent to you have any acid area with not using so two is carbon used to remove the gaseous particle. What is principal and recovered? What is physical process? What is chemical process? That is physical process and chemical process. So absorption is a physical process, only attaching at the surface. There is no reaction happening. This is again based on many factors. Major factor is the surface area. So if it is having more surface area like activated charcoal, it will the gas molecule will get absorbed at the surface. So it's a physical problem. It's a physical problem, not especially effective against oxides of sulfur and the sulfate low molecular weight or delay. It will be good for particulate matter. Chemisorption is the one it will be absorbed and it will react also. So when gas or vapor molecule chemically reacts with the sorbent material, it's a absorption principle. Then it reacts with gas and forms stable chemical compounds. Then photocatalytic oxidation (PCO) having high surface area, medium coated with the catalyst such as titanium oxide. Titanium oxide, all the hospitals are painted with white. Even operation theater, if you go and see, it will be painted with white because it's containing TiO. Titanium oxide is bacterial resistant oxidation. So it will oxidize under bacterial emission into the atmosphere. So easily it will oxidize. Watch with the advanced oxidation principle. Hydroxide will be reacting with the TiO2 as a catalyst and it will be oxidizing all the pollutant. Even you can use UV as a germicidal agent. And plasma air cleanser, so it's having high voltage discharge to gases with high temperature plasma flame. So that's the thermal plasma cleanser. So accelerate the electrons to generate reactive ions and radicals. So air removal efficiency because it's directly having a contact with the air pollutant, so having a high removal efficiency for some gases or colors and particles. And ozone generated ozone. Ozone because ozone is an oxidizer. We will use in water treatment ozone, UV, CO2, CO2 is a catalyst, and then sulfate draining. So, oxidant used to oxidize the pollutants in the water. Same principle we can use producing irritating and corrosive products. It's the important of thing. The chemical reaction producing irritating and corrosive byproducts. And radons and its progeny. And we recommend the source control of so we cannot remove the building pathway for emitting the outside the building and above the building. That is the active soil depressurization, ASD method. The minimize the air above the slab or floor of the building. Then practical consideration for using portable air cleaners. Um, the indoor air concentration are not constant. That's the important consideration you have to have because all that I have discussed cannot be practically applied to all the windows, right? Not in the office, not in the home. So the placement of any portable air cleaner will so it's even not uniform concentration. Regular filter media replacement is required. Caution should be exercised and noise may be considered. So another concentration using input air cleaners, removal of pollutants is often limited by system operation, no system and not HAV system fan can be supported with high efficiency filters. Another major problem is byproduct emission. Whatever the techniques I have mentioned will have again a byproduct during cleaning. So PCO influences will generate formaldehyde, acetaldehyde, nitrous. N2O will be released from PCO, photocatalytic oxidizers. That is again NO2 will be the propylene. Monoxide will be released from this. So that's a byproduct again. So plasma air cleansers will produce ozone, carbon monoxide, formaldehyde, and byproduct. Even ozone generators are also producing ozone. That's the pollutant. So we have to think about the practical consideration before adopting each cleaning technology as such. It's the conclusion. Okay. So finally, we have a case study. I'll just show the results of the case study they have done in Mali, that is in West Africa. And that's the research done to calculate the particulate matter 2.4 in 2.5 in the city. How they did, I'll just give you a glance. So they have considered different activity in different micro environment, and they had highlighted the importance of sources to the people. That's their Mali, that's their aim. So how they have considered the sample? So Mali they have taken sampling from 2020 to 2021. So February, September, November, December, January, February. 6 months sample they have taken in different environment. So Africa and the population of 2.71 billion they have taken. I mean, that's the population of the Mali. So they have used P sensors. This is a portable, small palm size. So you can just hang in your so you can take it and it can be a sample. The people will access the sample during their own occupational time. So sampling procedure they have taken four occupation. One is office workers, drivers, DRI cooks, COOK, students. These are the four occupation they have chosen, and in the 3 days each occupants will carry this and the result give you the results, and they have a diary to note down every day the which and done. Okay, so 5 second interval it's taking the readings. Then micro environment what they have taken, school, homes, office. These are the what they have mentioned. Then how quality assurance they have done, and the exposure problem is the pressure at the time, the exposure, some this is only, and you can see the data here. So daily time series of PM2.5 and how it really works. And for which because I'm saying here, so insecticides and ISD are insecticides, ISDs are inserts. So these are all micro environment they have considered. And students, you can see more exposure is during school breaks. You can see 64 meter cube. And drivers, you can see 78 in home. And the cooks, you can see 300 in home ISCSTs. So that's the major all the emissions. The cooks in the homes are considered as a major build population here. So this is the result of the case study that we mentioned. So indoor during the Christmas is tea. So this is due to the second highest is the followed by cooking and cooking 150. So they have also highlighted the microenvironment. You can also go through the values and their health effects also they have told. So even one mosquito coil, if you burn, it will be equivalent to, it will emit PM2.5 equivalent to 75 to 135 cigarettes. So think about the emission levels. So PM2.5 will be from 75 to 135 cigarettes, how much it will emit? That can be emitted from one mosquito coil. So how much particulate matter it's emitting. Based on that, they also mentioned the health effects like asthma, like and wheezing, bronchial rhinitis, it will happen. So, on a conclusion, case study we can do in the smaller scale and so with the importance of indoor air quality assessment and the way to mitigate what are the source we can identify. It's a source of proportional technique. Yeah, identify the source. Who, which are the vulnerable population? How to avoid. We can also tell mitigation measures and recommendations to the population. Yeah. So what are the recommendation they have mentioned again? By proper ventilation, they have switching from sample and wood to because population are major exposure. So they recommended to switch from sample and wood to clean gases, solid biogases, reducing local emission from positive repercussion of the mitigation responses. You can also refer through this type of literature, that's the published articles. How to do more about this indoor air quality, indoor air pollutants and their health effects, how to mitigate and how to measure the different samples available for each pollutants. Hope you have think about this. If you have any doubt, please unmute and you can ask or you can put it in the chat box if you want. We will go to the problem solution if you don't have any question. So can I move to the problem solution if you have any, if you don't have any doubt? Yeah, thank you so much. Hope it is clear to you. I'll move on to the problem solving for this week. Please post the answer in the chat box if you know. I will read the question. Which type of health effect experienced after the exposure of air pollution can lead to chronic respiratory or heart disease and cancer? Chronic, chronic in the sense we have studied two things. One is immediate and short term. Another one is long term effects. So the options are short term effects, long term effects, immediate effects. There are no effects. They are asking about chronic respiratory or heart disease and cancer. It will be so long term exposure will lead to chronic respiratory, right? Yeah, that's what we have studied. Long term effects will give you respiratory disease, heart disease, and cancer. Yeah, option B. Yeah, correct. Thank you. Okay. So I'll move on to the second question. Which of the following pollutant is responsible for acute health due to the formation of carboxyhemoglobin in the blood? So we have studied about that pollutant, right? It will replace the oxygen in the hemoglobin and it will lead to dysfunctioning of the brain, the heart. So the name itself it mentions carboxyhemoglobin. What will be that? Carbon monoxide, lead, NO2, or PM. So the answer will be yeah. Carboxyhemoglobin will be formed by carbon monoxide, carboxy, CO, hemoglobin. You got it? Yes. The third question. Which type of samplers are used for long-term monitoring of nitrogen dioxide for exposure assessment? Tube type, bag type, question biomarker. For long-term monitoring, which will be useful? Tube type or batch type or a question type? Questionnaires are indirect measurements that won't be worked out for long term. And biomarkers are only for biological contaminants. For NO2, we can use tube or batch. For long term, we can use tube type, right? We have two types, one is tube and batch type. Tube type for low sensitivity samplers used for long term monitoring. Batch type of faster sampling suited for short term monitoring. Tube type is good, but it is having low sensitivity only. Yes. So the fourth question. Which of the following pollutants concentration is expressed in becquerels per cubic meter? This is the only pollutant having becquerels per cubic meter. What is that? Nitrogen dioxide, volatile organic compounds, formaldehyde, or radon? You can put the options in the chat box. Yeah. So becquerels per meter cube will be the unit for radioactive material. Which is radioactive here? Which is radioactive indoor air pollutant? Radon. Radon is the radioactive air pollutant. So option D is correct. Correct. So here you have iron concentration is expressed in becquerels per cubic meter. Yes. So we can measure the radon with the activated charcoal canisters. With, also extracted with the toluene. Alpha particulate tracker because it's a radioactive alpha particles will get emitted. That can be also detected. So again, match the type of mixing with the graphical representation. Because for ventilation or ventilation, we have four. In the box model, we have considered right in the modeling. Box models is based on four and based on four types actually. So first displacement will be coming in one end and moving in the other end at a different position. If it is coming with the same end and going in the same opposite end at the same direction, then it is a carry. Piston is pushing from the top and moving at the both the ends. Mixing is coming from the one end and going through the same end. That is called mixing because it's mixing the end. So option is P1, Q2, or piston is 4, mixing is third. So option D is correct, right? Sorry, 3 S3 no? C is correct. Yeah, P1, C, Q2, piston is 4, mixing is third. Correct. So option C is correct. So this is like four types of mixing in the box model in a closed environment, the windows. question. Which of the following indoor air quality modeling techniques is only applied when moving source occur within a confined space? So we have discussed, right? Whenever there is a moving source, like a train or a signal or a car moving in the tunnel, train moving in the tunnel, people representing moving inside the road. So if the source is moving. So what we can consider like box model, analytical tool, Egyptian model. It's not box model, sorry, because it's a confined space, but moving source. Box model will be source will be there, but only the dispersion will happen. But the source itself moving means it will be advection model. Please check your answer once. Here you can see advection model. Many times the source exists that is moving within a confined space. But box model, source will be there, but the air will be moving or the media will be moving. So it's called box model. What are the other things? You got it? Yeah. Thank you. Then in a fibrous media air filter, the MERV, what is MERV? Minimum efficiency reporting value. So based on the efficiency for high efficiency particular filter will have how much it will be. Lower than 1, 1 to 4, 5 to 13, 14, 16. They are asking the MERV value for HEPA, high efficiency particular gas filters. So we have different filter types based on its efficiency. HEPA is having highest efficiency of 14 to 16, right? Here you can see higher efficiency filters, HEPA, that are having MER value of 14 to 16. Yes. So the eighth question, which of the following air cleaning technology can generate nitrogen dioxide as a byproduct? Because we are discussing cleaning technologies like ozone, what is that? Purposefully generated ozone, UV, filters, and then photocatalytic oxidation. These are all different air cleaning technologies. Which air cleaning technology will produce N2O? It's not C. Photocatalytic oxidation, plasma air cleansers, electrostatic precipitated, fibrous media filters. It's not C. Is it C? I'll check once with the PPT. It's not C. I think photocatalytic oxidation will produce nitrogen dioxide. Okay, you are confused with which technology is to clean nitrogen dioxide. I am talking about which technology will produce nitrogen dioxide as a byproduct. So photocatalytic oxidation. See here, some cleaning technology emit harmful byproduct during operation. PCOA, the photocatalytic oxidation generate formaldehyde, acetaldehyde, nitrogen dioxide, and carbon monoxide. Plasma air cleaners also producing carbon monoxide, formaldehyde, and ozone. ESPs, if you see, portable and duct-mounted ESPs, ionizers can generate high amount of ozone, not N2O. So ESPs are creating ozone. Okay. Please check your answers. Thank you. The ninth question. In the case study related to personal exposure to fine particle, what was the duration for sampling of the that I forgot to tell you, sorry. For the Mani case study, they have taken minimum sampling period of 72 hours was the for the participants to hang that sampler. That's a palm sampler they have hanged in their neck, right? So they have taken a minimum of 72 hours. That is 3 days. That is 48. Uh, 3 days. Mentioned 3 days minimum. Yeah. So they have to take a sample at least 3 days in all microenvironment that I have mentioned. So participants should be hanging there for 72 hours or 3 days. So the last question you can answer. In the case study related to personal exposure, the expression for calculating the exposure to PM2.5 is given as what is the exposure formula? Concentration every time, concentration every time, concentration every time. So exposure is concentration in the time. Yeah. So that's the exposure they have used. So total average concentration recorded in micro environment and the time. That's the product of concentration and will give you this average exposure. You got it? Yes. So that's it for today. So thank you so much for joining today's live session on 7th week session. So don't forget to give your assignments on time. So I think tomorrow will be the deadline for week 7 assignment. Please finish it off and if you're giving for examinations. So most of the exam question will be from assignment, I guess. So study. I think this course material will be enough. I am uploading the material as well as the course material in the um, Google Drive link. I think you already know about the Google Drive link. I will show you once again if you want. So you can go to the point portal, you can go to the course. So below week 7, week 8, you can find problem solving session. And here you can find my associate problem solving recordings. We go to there, you can find new tab that will be having all my 6 weeks recorded videos in YouTube. And this folder, if you go to the Google folder, you can find the material what I have taken, from source material only. I can read material, then problem solving material what I have created. Also, I have posted some of the reading material for you to solve the problems. So you can also go through this. Okay. So I will post today's video by tonight, and you can also read if you missed any. So thank you so much for joining. So if you don't have any doubt, you can leave the meet. I'll be there in the meet for next 5 minutes. If you can any doubt, you can ask. Unmute and you can ask, or you can post it in the chat box. Thank you so much. If you don't have any doubt, you can leave the meet. Thank you. Next, we will meet next Tuesday, 6 to 8. Thank you all. No issue. If you missed one assignment, that is no issue. We have already discussed, right? This thing. I'll show you again if you want. Yeah. So the about the course, if you go, you want certificate, you have to give assignment. Out of 12, best of 8 assignments will be considered. So you can miss 4 assignment, not a problem. But if you want full mark, for the 8 assignment, you have to have 100 marks. So you can see the mark in the progress. So 7 weeks marks you can see in the progress. So one assignment, if you miss, no issue. So out of 11, best of 8 marks will be considered. I think I missed the 3 assignments. Sir, will we have multiple choice? Yeah, it will be like same multiple choice, I guess. Or some numericals, I don't know. There won't be much numericals, maybe fill-ups. Mostly it will be multiple choice. No worries. And to get certificate, you have to have minimum of 30 marks in the exam and 10 marks in the assignment out of 25. That calculation also you can go. I think nobody will be that much low, so no worries. Yeah. Thank you so much. Yeah. So I think there is no more questions to ask. I will end the meet. Thank you all for joining. We'll meet next week, 6 to 8 Tuesday. I'm closing the meet.